Hi guys! In this video, we're gonna talk to you about our senior project in Kasetsart University, and we are proud to present KU Eater, Let's Find Your Food. KU Eater is a web application that used for recommending, reviewing, and rating food in the KU cafeteria. The reason why we decided to do this project is because cafeteria is one of the most common eating location choice for the student. But from too much of food choice, we find out that there are many students who overuse the cafeteria, stuck on the situation like, what should I eat? And then they have to walk all around through the cafeteria just to find one meal to eat, which is waste of time. But what if they try to pick some random store? It may not satisfy with the choosing meal. So we think it will be great if we can create some platform that can provide information about menus and food store in the KU cafeteria, and also can recommend the menu according to the user preference. This way can help user make the best decision about the meal in university just a few minutes on the phone.
We want to talk about the other solutions or the competitors. So we got three of them as the prominent examples for KU Eater, which is Wong Nai, Ready, and Open Rice. Wong Nai focuses solely on Thailand, Ready focus on Japanese, and Open Rice is for the entirety of Southeast Asia. So why we are different from them? So first of all, KU Eater has a kind of small scope which focuses on the scope of cafeteria in Kasetsart University. Users can actually state their dietary restrictions. So when we bring you recommendations, we make sure it fits perfectly with your profile or how you have your diet, and users can also see the individual dishes information and score instead of having to see the entire store or entire restaurant as a whole. For stakeholders, we first think of the food stall owners and what they get from this. So they get information and data that we can give to them on how students behavior, for eating in cafeterias, on what they want, what they like, and the trend for them. And also the users, for our main users, we went to go with KU student, but there's also more of them. So exchange student, professors, staff, or even guests that came to Kasetsart University, they are also in a part of the users. For the user stories, we start with menu items at fingertips. So we wanted everybody to, be able to see the menu at every time on their phone or where to go. So that's what we want to do as a first priority. They can search food items with specific names. So we have a system that will kind of like differentiate, or we'll be able to recognize different names for items. They can review the menu or items. We can review menu items or the stall offering those. And they will get recommendations on food items based on their preference. So what they like to eat or what they have seen before, or something's trending, then they're going to get straight to that. And they can filter food items based on the preference, like any dietary restrictions. Our system can do that. And they can compare the similar dishes of different stalls. So when some kind of like a stall will have the same item, have the same menu item or alternative that is similar enough, users will get more wide range of choice to go on and pick a stall that may be their favorite. For the use case diagram, so it's kind of like essentially users will be able to view recommendations, see the menu info, search for menu items, they can read reviews, while the authenticated users or members, they can write review, rate menu items, and edit a profile. In the domain module, we have likely menu items which need to include ingredients, and the stalls will include those menu items. So there will be, some reviews attached to the menu item where the user will be able to be the one who wrote them. And we wanted to, kind of like separate between the user and user profile. So I'm going to do that. And most of the things inside here, they need to be readable by recommendation engines. So now we get to the point for the modeling of the recommendation engine. At last time, we got an invaluable feedback from the committees, and we decided to take a step back and try to refine and redefine how the recommendation engine should be. So first of all, we scrapped the idea of using the gated recurrent unit the RNN technique away because that requires a lot of data. But for KU eater, we don't think that's sufficient enough. So we just come up with, we could just come up with a recommendation engine that will go suit well with most of the modern recommendation engines, which is using item-based collaborative filtering with KNN. So the parameters for training this model is that menu items will and menu categories. Those two datasets will need to combine with each other, and then they will go with the similarity, kind of like a test on how similar two many items are, and then they are going to have stalls which create an entry between the menu items along with that, and will produce a dataset of possible recommendations for all data. And any user parameters will go through the recommendation engine. They will go through the KNN to see what preference from user matches the most with the KNN, and it then will take those similar menu items and filter out as a list of predicted recommendations. Of course, we do not stop there because we can need to talk about the parameters that we use. The first parameter is recently seen items, and there will be review items and liked items. All of those three will be put onto the recommendation engine in order to spew out those lists of predicted recommendations, which makes the most sense for us. And then we have some extra parameters or attributes in the user profile, like dislike items that will reduce the score on dislike menu and prevent them from appearing too often or at the top. And we have dietary restrictions. We need to filter out those menus that met the restriction criteria. For example, like shellfish allergy, we need to filter out those menus with shellfish, and then we re-rank them all and put into a rank recommendations list based on the score.
Next, we will talk about the KU Eater Mockup. As you can see, user can sign in when they enter to the app, or in case of first meet, user can sign up and input some basic information, including the dietary restriction, their meal preferences, and some sample of favorite dishes that lets our recommendation engine work on the first visit. After this part, user will see the homepage of our application, which already had some recommended menu and food store aligned with their own preference. And as you can see, we also allow user to tap the like, love, and save button, which can help us analyze more on the user preference and eating behavior. In above of the page, we have the search button, which can search for the specific keyword. And here is the food store profile, where user can see the menu below and tap on the review part to see the review and rating the store. And for the last part, we're gonna talk about our project planning. Now we have about 7 main tasks to finish the project. For now, we are working on the data acquisition and designing part, and we will start the implementation part about this June. If everything are on the plan, the KU Eater project will release the full version on the March 2025. And that's it for today. Thank you for your attention.